I am going to start a lecture series on differential equation for undergraduate students. So I have some reference book for differential equation. One is the differential equation and integral transform by UP Singh, Nilkamal Prakashan, and second is the differential equation and integral transform by A.R. Basishtha by Krishna publication. Okay. Now we have to introduce about differential equation, that what is mean by differential equation. Simply D is differential equation. And why we study differential equation? Differential equation. Now let us consider an example is radioactive decay. Radioactive decay. This is given by dN by dt, rate of decay of an atom is equal to minus lambda n0. This is the law of radioactivity, in which this is dN by dt means the rate of decay of a substance of an atom. Another example is Newton's law of cooling. Newton's law of cooling, and this is stated as the rate of cooling of a body is directly proportional to the temperature difference between body and surrounding. So Newton's law of cooling is written as dt by dt is equal to C any constant T minus T0. This is the temperature and is multiplied for time. This rate of cooling, rate of change in temperature or cooling of a body is proportional to T minus T0. Okay, another example is Newton's law of motion. Newton's law of motion, and this is given by m d2x by dt square is equal to force, x for displacement and t for time. So in all three equations you see that there are a certain quantity and its derivative. Dt by dt is the derivative of temperature, dN by dt is the rate of radioactive decay. This is double times differentiation of displacement. So the equation of types which contains derivative of a function, the equation which contains the derivative of the equation is called differential equation. So this is the differential equation, this is the differential equation, this is the differential equation. Okay, why we study differential equation? So in physics, chemistry, biology, economics, finance and many more fields of study has the equation like this, rate of change of a certain quantity. So this is very important to study about many subjects. So differential equation is very important. Now so we can define differential equation as the equation which contains derivative of a function. Differential equation is defined as the equation which contains derivative of a function. Derivative of a function with respect to one or more than one variable, more than one independent variable. Independent variable. This is the independent variables. What is meant by independent variable? So variables are of two types. One is the dependent variable and another is the independent variable. By writing a differential equation, you can distinguish about these variables. So this is d2u by dx square plus u is equal to cos x. This is the differential equation because this equation contains derivative of u. So variables are of two types. One is the dependent variable and another one is the independent variable. Independent variable. Okay, dependent variable means the function, solution of the function, just like in this equation you see here u. So solution of this equation is is in the form of u. So this u is the dependent variable which depends on parameter x. So dependent variable can be defined as the variables which consist a number of solution of unknown function, which consist a number of solution of unknown function. And in differential equation, this dependent variable is generally appears in numerator. Okay. Independent variables means the parameters of the differential equation. Parameter means how is the dependent variable is depends on another quantity. That quantity is in this equation is x. So this x is the independent variable. So easily independent variables means parameters of the equation. Parameters of the equation. And in differential equation, independent variable generally appears in denominator. So this appears in denominator and this appears in numerator. Now we have to classify differential equation. So classification of differential equation. Classification of differential equation. There are two types of differential equation. One is ordinary differential equation. This is ordinary differential equation, and in short we write ODEs, the ordinary differential equation. Second is the partial differential equation. And in short this is PDEs. Okay. Now let us consider a differential equation that is d2u by dx square plus du by dx is equal to cos x. So this differential equation contains dependent variable u and independent variable x. So easily we can say that this differential equation has only one independent variable. So this differential equation depends on single variable, single independent variable, and that variable is x. That's all. Now the differential equation which is depends on a single variable is called ordinary differential equation. Okay, the differential equation which is depends on a single variable is called ordinary differential equation. So this equation is the ordinary differential equation. Okay, now another example is del 2u by del x square plus del 2u by del y square plus del 2u by del z square is equal to 0. Is the Laplace equation. In this equation there are one dependent variable u and there are three independent variables x, y and z. So we can say that the function u it depends on three independent variables x, y and z. So we write here u, dependent variable u is depends on three independent variable x, y and z. So the differential equation which depends on more than one independent variable. Once again, the differential equation which depends on more than one independent variable is called partial differential equation. So we can write one by one the differential equation which depends on a single variable is called ordinary differential equation, and on other hand the differential equation which depends on more than one independent variable is called partial differential equation. So basically we can write the differential equation which depends on more than one variable is called partial differential equation. Now we have to understand what's about order and degree of a differential equation. So order of differential equation, order of differential equation. Order of differential equation means the highest derivative that appears in the equation is the order of the equation. So let us consider an example: d3u by dx cube plus u is equal to cos x. This is the differential equation, and in this differential equation the maximum order appears is 3. There are 3 times derivative of u. So order of this differential equation is 3. Order of this differential equation is 3. Okay. Another example is the Newton's law of motion. M d2x by dt square is equal to force. So in this equation you see here there are 2 times derivative of displacement d2x, 2 times derivative. So this differential equation has order of 2. Okay. Another example is dy by dx plus yx is equal to 0. In this equation there are one derivative of y, so order of this equation, differential equation is 1. Now I think that you understand about order of equation. Second is the degree of differential equation. Degree of differential equation. Oh, okay. We can define order of differential equation is the highest derivative of dependent variable which appear in the equation. This is the order of differential equation. Now, what's about degree of differential equation? So we understand by example. Suppose this is d2y by dt square plus dy by dt square plus y is equal to 0. So order of this differential equation is clearly 2 because the highest derivative of y is 2. First about degree. Degree means the degree of highest derivative. So first we have to see what are the highest derivative of this equation. So this is the highest derivative. 2 times, this is 1 time, so this is the highest derivative. And what is the power on this derivative? This is 1. So degree of differential equation is 1. Degree of differential equation is the degree of highest derivative. Similarly, we can write here the degree of differential equation is the degree of highest derivative which appear in the equation. Okay, that's all about order of differential equation and degree of differential equation. Now, what's about the differential equation of order 0? What's about the differential equation of order 0? So, differential equation of order 0. Differential equation of order 0 means there are no derivative in the equation. So we write here differential equation which has no derivative, order is 0, is called algebraic equation. This is algebraic equation. So for a differential equation, the order of the equation should be is equal to 1 or greater than 1. So for differential equation, order of equation should be equal to 1 or greater than 1. Okay. Now the first order differential equation, second order differential equation are more obvious, and third order differential equation, appears in the solution of wave in dispersive media and water wave. So third order differential equation appears in the wave in dispersive medium or water wave. Fourth order differential equation appears in plasma wave, beam mechanics, etc. And the order of the differential equation of order 5 or greater than 5 are very rare. study of differential equation. Now I am going to introduce you about some notation which is very useful in the study of differential equation. So next is the notation. To represent ordinary differential equation means the equation which depends on a single variable. So to represent ordinary differential equation, there is a notation called Leibniz notation. This is Leibniz notation. This is D for ordinary differential equation. For example, this is d2u by dx squared plus u is equal to sin x. This is the ordinary differential equation, depends on a single variable, and this is written in the Leibniz notation D. Another one notation is del, sometimes called deca, is for partial differential equation. This notation is called, this is del x any independent variable for partial differential equation. For example, this is del 2u upon del x square plus del 2u by del y square plus del 2u by del z square is equal to 0. This is the partial differential equation, depends on three variables x, y and z. So this equation is written in the form of del. Once again, if we have to write the ordinary differential equation, then the equation is to be written in Leibniz notation, and when we have to write the partial differential equation, we have to written in form of del, not d. Okay. Some other notations for partial differential equation is we write del x in subscript in the place of del x, and del 2 by del x square is written as del xx, 2 times x in subscript, means there are 2 times derivative of a function, or this may be written as del x square, del 3 by del x square del y. This is written as, there are 2 times of 2 times derivative with respect to x, so we write here del xx, and 1 time derivative with respect to y, so this is y. This is the notation for partial differential equation. This may be written as del x square del y. As you are convenient, you can use that. Okay. What is the more notation? We have to, if we have to write dz by dt, differentiation of z with respect to time, then we write this differentiation at z dot. This is z dot. Like velocity, this is dx by dt is written as x dot. This is the velocity. d2x by dt square is x double dot. Means we have to, if we have to differentiate with respect to time of any function, then we write that function in form of dot. If 1 times derivative, then 1 dot, 2 times 2 dot, and so on. If we differentiate a function with respect to position, now let us consider this is dz by dx. This is the differentiation of z with respect to x. So this is written as z prime. Once again, when the differentiation is with respect to time, then we write here dot, and if the differentiation is with respect to position, then we write prime. And it is not necessary it will change from book to book, and but simply this is the method for writing the differential equation. Now all. We see here some differential equation that will appear in physics, that is m dv by dm plus v square is equal to v. This is the differential equation. This is appears in rocket flight. Second one is the del 2u by del x square plus del 2u by del y square plus del 2u by del z square is equal to 0. This is the Laplace equation, which is used in electromagnetics also. So this is the Laplace equation. Okay. Another is del u by del t is equal to c square del 2u by del x square plus del 2u by del y square. This equation appears in diffusion of neutron. And so many equations. This is appears in chemistry also and physics also. So that's all about the differential equation and its classification. And classification are as the ordinary and differentiation. Some other classification of differential equation as the linear differential equation and non-linear differential equation. So another classification is the linear differential equation and non-linear differential equation.